Hey guys, Brian Beeler here at the Storage Review Lab. Thanks for joining in on this podcast. We've got an exciting one. I've got a human in the room next to me. Allyn, how you doing?
In the room, my goodness.
I know. So Allyn's with Intel. Why don't you tell the world what you do at Intel?
I am a storage technical analyst at Intel. So
What-
anything like sort of jack of all trades storage, be it Intel platform storage performance,
Okay.
SSD storage performance, not just Intel SSDs, but even competitors to Intel, their SSDs on our platforms, right? That's still a thing that needs to be have an eye kept on and make sure that some particular SSD doesn't do something, unexpected on an Intel platform, right? So there's lots of that other kinds of testing that goes on. Any performance claims that we want to do, usually that sort of stuff comes through me just to do the reality check and make sure, okay, did we configure the systems properly? Did we run the test properly? Are we being fair? That sort of stuff.
Okay.
So,
All right, and so today what we're going to talk about is a little bit more on Gen5 SSD performance. So Allyn's background's perfect for that. And Gen5 has been coming really hot on the heels of 4. I mean, the cycle time between PCIe Gen 2 to 3 and 3 to 4 felt like an eternity. 4 to 5 has been a light switch.
yeah.
Just super rapid. What do you attribute that to, if anything?
I think there's a lot of borrowed, I don't want to say principles, but just like when they were working on 4, they were thinking about 5, right? So there's just, it's sort of...
Better planning?
Probably better planning, probably just like let's not go so many years between iterations again. But then if you put so much thought into 4 with the 5 being the next extension of it, then I guess the end result was that the gap closed a little more than we expected on the time period.
Well, PCIe SIG's already working very publicly on 6, so it's not as if that's even that far away, which is really kind of cool because from a storage perspective, this opens up doubling and doubling of potential performance, right?
Yeah, and it's not, sometimes there's catches or gotchas or things like that where it's like, oh, but it's only in this particular, because of this trick, it's able to kind of get to double the speed or something like that. No, this is pretty much 2x, like just a flat 2x over 4.0, which is, the only real catches or gotchas is that you start getting to the point where you're going so quickly that you run into diminishing returns on the other things, like the thing that is, the code that's talking to the SSD, the software, the, responsiveness of the cores in the CPU, things like that, where even if you're doing relatively large transfer sizes, you're doing so many of them at such a high rate that you start running up against like, oh, I'm pegging a core, but I'm doing sequential, which is usually not the case, right? Yeah, usually, for folks doing storage testing like myself, and even you guys are doing plenty of storage testing, right?
Yeah.
If you're doing your random, your IOPS type tests, those are the things where if the device is fast enough, chances are you're going to need more than one core, and you're going to start rationing up cores for your test system. Sequential, we're used to just, oh yeah, that's just one thread, right? Mm-hmm. It's almost not the case anymore now because of this. There's just...
So so there's two different things, right? Because, and you've got products sitting here, and sorry, this one's a little more visual, so if you're listening, it's worth checking out the video just to see some of the stuff that we're talking about.
Well, the listeners will, if they've been reading any of the news around CES, like Samsung just announced a Gen 5 capable SSD, right? A PM1743.
Yep.
I think there's some, the Phison rep has told me it's safe enough to talk about it now. So if your video goes,
we talked about it yesterday. It's okay.
Yeah.
The E26.
So the E26, that's another one.
This fellow.
I'm sure the other vendors, the other SSD makers are going to come in line pretty shortly as well. I'm sure there'll be a Silicon Motion one. There'll be other ones, right?
Yes.
But yeah, this is pretty quick, right? This is it's not only is it out, but it's everybody is announcing things. We have literally on the table here, we have a PM1743 that works. The firmware is not fully baked on it, but it will pretty much saturate Gen 5 sequentially.
We're going to see about showing that as well in this conversation too.
Right.
Phison, for me, so we had Sebastian Jean on from Phison. Mm-hmm. We did a pod with him a couple ago. I'll link to it in the description for this one. They're taking Gen 5 really seriously. Their E18 controller in the client space was super strong. We saw a lot of SSDs from Seagate, Corsair, Kingston come out on that platform. Really great performance.
It reminded me of Sandforce.
Though,
Remember that back in the day,
yeah.
Sandforce was in everything?
Yeah,
It's
absolutely.
Like, yeah.
Yeah, and now, well, I mean, for Phison, it's really exciting. And if you don't have a fab, it's really exciting because now I could take this reference design and immediately go to Gen 5.
Yeah, it helps with adoption.
Oh, I mean, it should be there close to day one. Is that your expectation?
Probably. I think I'm not sure how this is going to actually play out because I haven't been keeping a lot of tabs on it with respect to like the power consumption. But I would think that we have a demo piece right here. We have an M.2 E26. I just think that you're getting to the point where you might not be able to get away without a heat spreader or possibly a heatsink.
Well, it's an interesting thing because, right, on the M.2 specifically, heat dissipation, most of it is through the connector.
Yeah.
And then,
or there'll be a
half.
pad between the board.
Yeah.
Sometimes you see those little, I can't show it on this system, but.
No, but on modern gaming boards, they'll normally have 2 or 3 slots on the board.
Yep.
Covered with their own little squishy piece, sticky piece, and then a metal thing on top.
Yep.
And maybe half goes out through the connector and half goes through the heat sink. And in that model, the heat sink is part of the board design. So that's going to be important. I don't think, to your point, we're going to see bare M.2 just kind of chilling loose in a system without either an included heat sink or some additional heat dissipation device on top.
Right. And the funny thing about that is that for the most part, the reason you even need that is for the edge case where someone's running like a benchmark.
For guys like us?
For guys like us, yeah. Because for the most part, like especially if it's a mobile system, where are you even going to get the data from or send the data to for you to be able to peg something at upwards of, almost 14 gigabytes per second?
Well,
right?
It's pretty edge, right? But some of the data scientists, AI, ML guys that are doing that on mobile workstations, again, it's not millions of people, but dozens probably.
Right. But even at that high of a data rate, I mean, you're getting to the point where you could just go the whole SSD front to back in under a minute. So it's just super fast, right? So in that case, in many ways, for many workloads, the bottleneck is really going to start pushing the other way onto either the thing that's processing the data, or if you have a mobile workstation system, chances are it's even workstation class system still, but mobile form factor, there's just not enough compute there to even be able to chew through 14 gig per second.
Okay, so that brings up the point on client systems.
Right.
Who cares about Gen 5?
And so that's where I'm kind of still a little bit, I'm not sure how it's going to pan out. I wouldn't be surprised to see plenty of like mobile, just your kind of run-of-the-mill average Joe mobile systems. They might move to Gen 5, but I wouldn't be shocked to see like just 2 lanes of Gen 5.
Okay.
Right. So yes, it's the same as your previous, Gen 4 by 4 SSD that would have been installed in there as well, right? But you could drop it to 2 lanes. You could potentially use those lanes for something else. You're more lane efficient, right? And at the same time, if you're only using 2 of those lanes, potentially you're doing it, the same or maybe better power consumption on the SSD side, on the device side.
Well, on portables, power consumption is obviously huge.
Right.
So if you could do something there, then that's better.
Yeah, it just gets to the point where it's like, do you really need to do that much power consumption involved with transferring that much data that quickly for just like a, your grandma's checking email kind of system?
No, because they're going to run some 670 or something in them and be fine, or your H20 or whatever.
That's true too. Yeah, but eventually, as those products phase out, like 5 years from now, what's going to be in your simple check the email system?
Gosh, we'll all be living in hologram universe by then.
Hopefully. But,
for you,
but what SSDs are going to be in our computers, right?
All right. Well,
yeah.
Okay, so we think about that. Then on the PC side, obviously the first thing is gamers, media and entertainment people, engineers, architects using heavy CAD files, things like that need to move things around to local systems for processing or interaction.
So, some of the motherboard makers have already kind of been leaning in that direction. just with respect to Gen 5 SSDs in the M.2 form factor, right? Because if you look through all the various Z690 boards that are out now, you'll see some of them, the system we have here happens to be sort of one of the other configs than what I'm referencing here, where for this particular system, since I have two of these Samsung drives, they're in a U.2 form factor, they just don't slot into an M.2 slot.
Yes.
We have to use these special add-in card adapters to plug them in. So this system is set up in such a way where two of the standard PCI slots will connect at 5.0, right? But there are plenty of other more gaming-oriented. It's almost seems like around 50% of the boards, or maybe a little bit shy of that. But instead of having the second slot able to go Gen 5, they will sort of repurpose those lanes, and those lanes will go to what is like called, not the primary M.2 slot, but they will have an M.2 slot that uses 4 out of the 8 lanes that would be like the second half.
So they'll max the lanes to 1.
Well, no, they'll have an M.2 slot that gets 4 5.0 lanes on it.
Oh, okay. So
right. It's just you have to really look at the specs for those boards to see that, okay, this particular one is this variation where it does that. The catch is that you don't get a second graphics capable slot that it runs at 5.0.
This is going to
right. They just sort of rearrange them.
This could be a little bit of a nightmare for the systems guys, Dell, HP, whatever, because they're
you have to pick a direction.
Right, the disclosures for what you want to do. And maybe it helps them. Maybe Dell on Alienware does something different with their configurations than on Latitude and Precision, for instance.
Yeah, and I can see why they're torn, because so I'm pretty thrilled on Z690 because I think it's like we've kind of finally got it right with respect to the flexibility of the storage connectivity. Right, the chipset has a higher link, so now you're not so much even if you decide to put a few NVMe SSDs in a RAID, you're not running into bottlenecks as easily, right? You have more bandwidth to the CPU that way. There's more flexibility with respect to how you can array the drives. Well, if you think back to X299, where it's like, if you want to boot from the array, it has to be within this thing called a VMD, and there's all these extra little gotchas and tricks and conditions. Whereas now, Z690, you could pretty much put your M.2 SSDs either off of the chipset or off of there's the 4.0x4 dedicated off the CPU, right? You can actually mix and match those. You can have an array you can have if you had one slot that happened to be off the chipset and the other one was off the CPU. It's less than ideal because the latencies are a little bit different, but you could actually do a bootable RAID across, those two devices, right? Which previously wasn't an option, wasn't something you could do easily, or maybe even not at all, depending on the system. But there's all this extra flexibility now, where there's even some of these Asus boards that I've seen where there's enough M.2 slots on it where you can have 3 NVMe M.2s, PCH attached, and then 1 or even potentially 2 more M.2s in the system. One of them using Gen 5 lanes and the other one using the 4.0 CPU lanes. Okay. So there's all this extra flexibility there with respect to how you do your storage connectivity. But again, the more options the OEM has, it might lead to some confusion with, how many different configurations do they want to spin off?
Well, I mean, the gaming guys already make various iterations of boards depending on what price band they want to target.
Yeah.
In the mainstream, I don't even think you can worry much about the mainstream with Gen 5. It'll either be there or not, but those users aren't typically going to be aware of that or want to make the investment. So we'll see it strata out by price band too, right?
Right, yeah. It's spread out that way. But it's I don't want to say it's confusing. It's just that there's more of a need for you to do your research before if you're DIYing a system, you really need to look into some of those other details now, because there's even more, variation of more SKUs available for this particular generation of board because of that extra added flexibility that was there and what those motherboard makers are doing with it.
So what's the enablement required for Gen 5? It's not. I mean, there's a couple different things, right? There's new technology coming down for both client and enterprise in terms of next-gen processors, but talk about what the requirements are. Will people be able to BIOS update old boards and now they're Gen 5 capable, and then maybe talk a little bit about this system specifically, what you have to do to get Gen 5?
Oh, for everything I've seen so far, it's all been, where are those particular sets of lanes physically wired?
Okay.
It's simply down to that.
So that's a
right?
prior design decision that's already obviously been made in shipping product.
Yes.
Okay.
To have any additional flexibility, folks would have to install a MUX or just some other sort of chip on the board to route those lanes to different places if they wanted to, right? But as it is, in the case of the 12th gen Intel CPUs that have those 5.0 lanes on them, they have 16 of them, and then what you want to do with them is sort of up to you as a designer, of a either a system or a motherboard.
Now, those CPUs, I believe, are being shown off this week at CES. I don't
The
know.
12th gen?
Yeah.
I mean, they've been out.
Yeah. Well, they had a couple more SKUs or something. I don't follow the CPU.
There's some talk about an S SKU, which we've done in the past, where you have like a even higher clocks on something, right? I'm not sure what level of detail is out on that, but I do know that an S SKU, an S class like CPU was discussed, like just a faster one. And that's just pushing clocks higher. In this case, getting up to like a turbo of 5.5 gigahertz, which is pretty fancy for something that is not like considered an overclock. Like it's out of the box. This will do some number of cores at 5.5 gigahertz, which is pretty cool.
So for existing boards that people already have that want to get a Gen 5 SSD whenever they're available, just knowing where to put it is probably the most important thing.
Right. You're either going to have a board that had some number of lanes sort of ported over to an M.2 slot, so that would be your easiest for your average Joe.
Probably
sort of,
zero on most of these, I would guess, but I don't know, maybe not.
Well, so the way it ends up working out, like logically, like as far as how it presents to the system or how the system like enumerates things, it would show up as the first device because it's actually what would normally be the second GPU slot. Right, because it's the 16 lanes that you can split into 8 and 8, and in the case of those boards that are routing Gen 5 capable lanes to an M.2 slot, they're just taking, when you install that SSD, the GPU drops down to 8 lanes instead of 16, and it takes the other 8, uses the first 4, puts them on the M.2. So
it's a lot of lane management, which is going to be interesting.
There's that piece of it. There's also the fact that currently with these configurations, if you're not, remember, you still do have a set of dedicated 4.0 lanes for storage, right? Which doesn't use the chipset. They go straight to the CPU as well. But if you want the faster lanes, the compromise is that you're now taking half of the lanes away from the GPU, right? Which might be an issue in most of the testing that I've seen or done myself. If you're already going, if you have a 5.0, PCI 5.0 capable GPU, and you drop it to half the number of lanes, well, now you're the equivalent of 4.0 by 16, first of all, right? And also, like in a lot of testing we've done, 4.0 by 16, even that, with like the heaviest, craziest GPU workloads, was still plenty of bandwidth. Like you could even cut that in half and be hard-pressed to even notice a difference, for most of the things you would do, right? So with the extra speed of 5.0, you're probably even more likely to get away with that GPU-wise. So you can afford to give up half the lanes if you wanted to have crazy fast storage and crazy fast GPU, in the same system.
The same box, yeah.
Right.
So we talked a little bit about heat becoming an increased challenge. The faster we go...
Yeah, you're just going faster. It's the same that applies to network cards.
Yeah, right? Anything. Faster,
you got fire-breathing, super fast NIC. It's going to have, a perpetually larger heat sink on it and higher airflow requirements and things like that.
Power envelope on the client drives first compared to Gen 4. What's different there in terms of power consumption, if any?
So Gen 4 was already kind of running up against other limits. Not so much cooling, but you're only supplying at 3.3 volts in an M.2 slot. And the pins are only rated for so much current. The spec is only so high. Right. It's around 6, maybe 7 amps. Watts.
Right. And after that, you can do no more.
That's all the system is rated to provide the device, right?
Okay.
So I think, some of the early Gen 5 devices might be a little bit of a balancing act there as far as you can control how much power the device consumes. The PHY, the actual thing speaking Gen 5, it's going to consume some X amount of power, right? Those things might just have to dynamically sort of control within that power budget. Even if cooling's not the issue, power delivery is still the issue. You only get so much total. So, I don't want to say that they would have to cut corners to do it, but they're going to have to make some sort of a compromise or be more dynamic about how they control how much power is going where.
Yeah, well, I'm just thinking along the lines of system builders that are very aware of how big their power supply needs to be to accommodate all of their system components. Any other design considerations there?
I mean, that probably shouldn't change because the prior gen SSDs were already close to the max of what you could draw on that 3.3 line anyway. And remember, overall, it's only 6 or 7 watts. So in terms of
total system, it's not.
Yeah, a total system is nothing, right?
Right.
When you get into laptops, things like that, it's much more significant. Although it's only significant when the SSD is doing that burst, right? Because most of the time it's going to be idle in a very, very low power state, right? That's one place where you might think, well, what on earth are you going to do with that 14 gig per second? Well, if you do your power budgeting correctly, like on the device level, on the device side, the SSD controller, if you do this thing called hurry up and wait, right, which is much more applicable to the client than the enterprise, right? But yes, you're using more power, but how many total watt hours worth of total power, not current, but like the total power consumption to say read 1 gigabyte worth of data, right?
Yeah.
And so the Gen 5 devices, even though they might use more power in that moment where it's doing the data transfer, the total power usage to complete a transfer of the same size might actually be lower.
Interesting.
Right? Because it's, yes, the bus uses more juice, but you got done
for less
quicker.
period of time.
Yeah, less time. Right? And there's more advanced things like dynamically adjusting the number of active lanes. Like that's actually a thing that can be done on PCI, where does it need, yes, it's 5.0. Does it need all 4 lanes to be hot at the same time?
Okay.
Right?
So like a scale up down based on...
You could, right? Like the system's only, as you get more and more advanced with controller technologies and firmwares and things like that, you could potentially figure out things like, that guy's just streaming a video from the disk. I'm only doing, I never need to go 14 gig per second ever in this workload. Well, maybe I can just be a little more intelligent about it and only use 1 lane, only intermittently, just give that person the next little chunk of video data, right? But you start getting into really advanced things where you have to sort of have more context, right? Like the system has to actually understand that, I am streaming video, which is kind of hard for just the device itself, like the SSD controller itself, to sort of get a lock on that you're doing that.
It may not know that, but the system knows what the active processes are. Right. Windows knows, or Linux, or whoever knows.
Yes.
This activity typically is this kind of workload.
Yeah, yeah, and those are the types of things that there's still plenty of room for sort of the PC ecosystem as a whole to advance with that sort of storage stuff. Right, it takes more grasp of the technology, more taking advantage of the knobs and the switches and the dials that you can turn, trying to make things better.
So on the client side, we're going to be looking mostly at M.2, although the Phison E86 does have a reference board that's an add-in card, which is not something we've seen a lot of.
That's probably, judging by the pads there for the power loss caps, I'm assuming that board is probably more meant for
light
data
enterprise,
center or light enterprise or workstation or something, right? Granted, I'm sure they're going to have U.2, right? Which, case in point, there's the Samsung part there right there, which is U.2. They're also going to have the E3.S?
Yep.
Right?
It looks a lot like this, a little skinnier, a little different.
Yeah, looks like that, except the connector sort of sticks off as if it was like a mini PCI card. Yeah. Instead of the U.2, which is the pins are inside.
Right.
So I mean, all the stuff's coming, but like what normally happens, it comes on the data center side first, or the workstation side first. Gen 4 is still plenty fast for client, right?
For client, and even most enterprise applications, right? Not until you're getting into some big data analytics and things like that can you really take advantage necessarily of all the throughput available.
Right, and that's the other thing that you have to realize, the media has to also come along for the ride. So you're only going to have so many dies, so much NAND on a particular thing. Yes, you can make the bus faster, but those devices are probably not going to do 14 gig per second writes, as an example, right? Because you can make it faster, but the media, you do shift bottlenecks elsewhere. So you have to balance, is it meaningful to make this particular product go Gen 5 speed given the other pieces, parts, in that device, or even on the system side, right? Does the system even
I mean, eventually it'll get to the point where it just is, because it's cheaper to produce the Gen 5 part than to maintain the legacy connector or interface.
Right.
So on the enterprise side, with something like the Samsung drive, what do you think that does in terms of system design, system challenges, innovation opportunities for the server guys? What do you think about that?
I think the biggest advantage there is just doing more with the lanes you have, right? That's, we just talked about a server, which may or may not be in a video that you've already posted.
Depending on timing, we don't know.
Right. But there was a server where we had
tons of lanes.
Supermicro server, a whole bunch of lanes going to the front panel. You could either have that same number of lanes with just doubling the throughput, right, which would be handy. Or you can use a lot less of them. You can get away with potentially fewer devices, fewer U.2 devices installed in the server, as long as the capacity was there. If you were worried more about the performance, potentially, or just specifically the bandwidth, now you can cut your devices in half that are installed in the front panel, right? And then you just freed up half of your lanes to do other things. And
maybe half of your rack footprint, honestly. If you're able to do that and consolidate down to one use or twin one use, I mean, there's a lot of opportunity from a density standpoint.
Right. Well, realize that effect compounds, right? If you, as the whole ecosystem moves from Gen 4 to Gen 5, not only have less devices, less space for devices installed in the front, potentially fewer lanes used per device for the stuff installed in the rear, as well, right? You have a NIC that needed half the width as the previous one. You get away with crazy 100 gigabit NICs that might only, how far could you potentially go? 4 or 8 lanes or something on like a 100 gigabit NIC if it was Gen 5, right? Because you're able to move that data on fewer lanes. And then again, that frees up those lanes to do even other things, right? You could potentially have I'm sure there are some crazy server builds out there where they just needed to do another socket just for the sake of lanes, potentially, right? And so for those cases, the next generation, you could potentially drop down to one socket, which would be cool. And that extends you into the things you were talking about, where you can shrink way down into a 1U, and then you can
we're
scale
seeing
out.
that, yeah. Especially in the enterprise, as we look at Ruler, there's a lot of E1S systems that having 24 of those in a 1U is less advantageous in their designs than having 12 and 12 go to 2 separate distinct systems. There could be one proc, but we've seen some cool stuff with 2 also. Yeah. Where you really need the computing power with the right affinity to data placement and data capacity. It gets really scientific at a certain point once you understand the workload. Yeah.
Yeah, but Gen 5 is just going to be one of those things that contributes to that, miniaturization, further miniaturization of a node in a rack. You'll be able to connect things quicker, fewer lanes, smaller footprint, and then that just lets you add another one of those right alongside of it.
Chunk
and then
another
just
node.
Scale out that way.
So we'll be running data centers on NUCs that are Xeon powered?
I mean, a NUC is a thing that is like one of those things where lanes it's hard to get a lot of lanes connected to a lot of things in a NUC, right? It's a super tiny box.
Yeah, it's a
right. And
4-inch square.
Yeah, and especially even if you go back to like where the NUCs had like SATA SSDs in them, like some of them they try to like make it a little taller and put a little cage in it where you can have you can do RAID of 2 SATA drives. And why would you do that? Well, not necessarily just for capacity. You want more bandwidth. So potentially, now you've got that NUC that only fits one M.2. Well, if it was Gen 5, now it can go faster.
I joke about the NUCs, but we have seen them deployed as HCI nodes. I mean, they're really pretty flexible for those little devils.
Yeah, even like back when I was doing the PC Per thing with Ryan Shrout, we had, for the longest time, the Office NAS was just a NUC. It's just a NUC sitting like with some drives connected to it. Like, I think it was like a USB Drobo or something plugged into a NUC at one point.
I'm not sure you should be admitting this.
This was before I moved to the office and changed.
I'm aware. This is in a former life.
Yes, former life.
I'm still not sure I would admit that, especially the Drobo piece. Yeah.
That was like, you just putting things, this was way early days on Drobo. This was like where the only Drobo was like the USB one, like the first one.
Their original Drobos were sick because you could put whatever you wanted in those things. It would just chunk them up and had a pretty UI.
Yeah. And again, things have clearly come a long way in other aspects of storage technology since then, to where you don't necessarily need to go that route anymore. But back then, that was amazing. You have a thing with 4 drive bays, and it didn't care, like you said, it didn't care what you put in. It just kind of it just worked. And if you didn't, you didn't have to have a person who even knew what they were doing. Right?
It was dead simple.
Just stick the drives in. They blink for a little bit. It comes up and it shows up as a device, and you just put your files on it. Right?
It's funny because we were talking about in here the other day. We've got not many small hard drives left, but we've got 8 or 10 random. There are no 2 that are the same.
Mm-hmm.
Between 1 and 4 terabyte, they're just kind of cluttering around. Yeah. And I was talking to Kevin. I'm like, "What do we got to do something? There must be something with these things.
Yeah, something useful.
Put in a Drobo." Like that's still the answer.
That would be even
10
today,
years later.
Yeah, that would be the simplest way to I just want to use all these drives in a redundant fashion, right?
In some way, yeah.
And I don't want to think about it. There's ways you could do some stuff on Linux. You could do, there's tools out there. There's
people, I'm sure.
Well, you could do that. There's even some other, I want to say, well, it is kind of DIY-ish, but there's other stuff out there, projects maintained by folks just on GitHub or whatnot that, will do surprising things while they put those drives together. But you got to know what you're doing with Linux, steep learning curve, even for that tool, and then you got to trust that it's code written by somebody, or you're going to really going to trust your data to that thing necessarily.
And there's no support for it.
Yeah, there's probably zero support, right? Whereas, again, sometimes it just makes sense. For the longest time, I used a Drobo as a backup device for my own personal system, just because I knew it could just be a box off in the corner somewhere that I didn't even really have to pay attention to, and it was just showed up on, it was a network style one, not the old USB
I remember
one.
When they added the gigabit on the back.
Yeah, they had a gigabit on the back, and I just had it mounted as a remote, iSCSI on the network, and I just threw stuff on it occasionally, and that was it, right?
This has nothing to do with Gen 5, but it is a funny Drobo aside. So I don't know if you remember. But they actually made a little rail kit for Drobos so they could mount them in a rack.
I've installed them.
Well, but they're half length and there's no support on the back, right? Yeah. So you put this thing in the rack, and what were those things? 3U or were they 4U big? They were.
I think it took a 4.
Whatever. So they were kind of thick, right?
But they had the ears that were like this wide.
They got the ear mounts, and you put them in a rack, and the ass end of it kind of sags down because there's no support.
The ears twist
they twist, they torque out, and they sag down. So I was talking to a Drobo guy at this time. I got food poisoning in Las Vegas.
Oh, great.
But before that, we had this conversation, and he was saying they worked with some players in the media and entertainment space, which was code for porn at the time. That had those as their storage devices, but they put them end to end because they were short in the rack, and they sagged down.
Using both sides.
They were using both sides of the rack, and they were running the cabling stack down the center because it was the cheapest way for them to get hard drive storage in a resilient way back then.
Yeah.
But if you can imagine how bad those ear brackets were, a full rack, both sides with the butts sagging into the middle, must have been something to see.
I mean, it was around that time when those were out that I had, for the Navy, I had assembled a couple of racks worth of storage gear for them to do. I worked at a command where they did any computer that got compromised or somebody hacked into something anywhere on the Navy's network, we would, send us your hard drive, right? And then it was basically a data forensics lab, right? So we needed a server to ingest all these hard drive images, right? And it was, I don't know what it was, like Apple Sand or something at the time they had.
Yeah.
That thing was like bubble gum and Scotch tape. Like if you looked at it wrong, the thing would just go down and just collapse on itself. And I was just like, we got to do something better than that. So then I basically just talked them into they started looking at we're going to do a contract for, we have to get bids from people and all this other stuff.
Go through the procurement process.
The typical procurement thing. And I looked at these quotes and everything, and I was like, do you have any idea how much storage you could roll your own for this? If you just bought some of those Shenbro, Shenbro at that time made a 9U that was a 48 or a 50 bay 9U.
Yeah.
Right.
Oh gosh.
And they were a couple of grand, or something, just ridiculously cheap. You still had to, do your own, like buy an Eureka card or something, just to like plumb it all in.
It's just so funny
Right.
though. In 4U, you can get in a standard length 4U server, you can get 102, I think, out of
Yeah, now.
Seagate or Viking or any of these guys.
Yeah,
with
it's nuts
computed.
now.
It's not even just a JBOD.
Right.
It actually has a little server in there.
Yeah,
too.
no, this thing was a bare bones.
Yeah.
Like you had to install the board yourself, and it was like not even server board. It was like desktop board. They just put a pocket on the back for you with like a standard desktop power supply in a rack mount,
Yeah.
chassis. But it was like such a hybrid kind of thing. But yeah, like we ultimately ended up like they were worried about. Oh well, if we do the contract, then we get support and everything. Well, I'll build you 2 instead.
Or
Like
more.
if you're for the cost of like just the support contract, I was like, if you're worried one's going to go down, we'll just make another. And we ended up we only needed 1 rack, but we ended up just building 2,
Right.
right? And so just
You
for
could,
redundancy,
yeah,
right?
yeah.
And it's the military. They usually have that sort of, especially my submarine background. Usually there's 2 of everything anyway. So
Well, now with all these object stores and all
Yeah.
these things, you can get triple, quintuple parity, whatever you want,
Right.
across racks or
Right.
or the cloud, obviously.
But it was just so
That's it.
comical that like we had to jump through all those hoops to like get this thing set up, and we're using hardware RAID cards, and because CFS wasn't quite far enough along for me to be comfortable
Right.
like doing it in a way where I was just going to hand it off, because if you're in the Navy, you don't stay at one place for forever.
Oh, that's a good point. The support mechanism
it needed,
changes.
just other people needed to be trained up on it, and we couldn't like teach people ZFS, like random sailors that just got out of high school, and like, here, you're gonna learn how to not destroy this data set by accident. Joe,
Yeah, go.
yeah, go ahead, go. So we just did it more dead simple, and like Windows with Eureka hardware RAID cards, which is one big hunk in volume, and then another big hunk in volume on the other side. And I even got it set up with like Windows Server doing like I forget what they called it back then, but where it would keep everything in sync across like 2 separate systems with 1 volume, right? That was all cool back then. But even then, we had one of those Drobos with the ears installed in each rack, and that was the backup for the server. And we would just throw drives in and literally did like a sneaker net offsite, sort of hybrid offsite backup, where it was actually written in a procedure where, install this set of 8 drives, run your backup, pull the drives, stick them in this, Pelican case, and go bring them over to the other building on the other side of the base or whatever. Just like move these over here, and
Still, it's still hard for data transfer to beat a geek in a minivan or station
some
wagon
Navy sailor
or
sticking it in the
whatever.
back of his Honda Civic.
Whatever,
and
right?
just
You
drives it
could
over.
fit more terabyte in an old Civic than you can in Amazon's Snowball or whatever. Whoa.
Yeah.
Anyway, I think we just did 9 minutes on Drobo
Yeah.
while we're talking Gen 5.
I don't even know if they're still
SSDs.
making new stuff anymore. I haven't heard from them in a long time.
They are around.
I know they're around. I don't know if there's new stuff.
Yeah.
CS
All right.
news cycle.
All right. Yeah, we're hot Drobo tech.
Drobo tech.
9-year-old Drobo tech. All right. So for this Samsung part, you're putting it in an adapter card. Talk about how that works with this system.
This is relatively straightforward. Serial Cables they've made these adapter cards for a while.
Well, they make amazing things for people at the edge of new technologies.
This
don't
is
they?
certainly at the edge of new technology. For example, this adapter card actually has one of the newer style PCI power connectors that you see on the new NVIDIA GPUs.
Yeah.
Just for debug purposes, in case the system happened to only have that available instead of SATA power.
Okay.
And the only reason this card has those external power connectors anyway is it's meant more for debug. There's all sorts of jumpers on it.
Yeah, we've seen this. I think we've got an M.2 sled that's got like physical switches on it where you can force some of those test states.
And that's meant for some, you're trying to do off. You need the drive to actually be offline. The system needs to be off. You need to do some sort of a firmware update through JTAG or whatnot. You just need some other way to power the drive. That's why they sort of make these cards the way that they are. So we only bought those because there wasn't a simpler solution out yet. The Serial Cables guy beat everybody else to the punch with having a Gen 5 capable adapter. But
so you've got 2 of them set up in this workstation, right?
Yep, we got 2 of the Samsung drives, 2 of the adapters, and a motherboard that happens to be that alternate configuration I was talking about, where it has Gen 5 lanes to 2 of the standard slots, and no Gen 5 lanes are going to the M.2 slots, which we needed for this particular config because all of our Gen 5 stuff is standard.
For anyone that cares, what do you know what board it is? Do you remember?
I think it's the Asus Apex board.
Okay.
There's some other words in there before, but Apex is the
Yeah.
it's like Maximus something Apex. And
Okay.
Yeah, it's that one that just happens to be that particular layout. There's other boards that have a similar layout. That was the one we happened to grab to do the demo. This is the system we were hoping to bring to CES in person to have as a demo, the typical thing where you guys would be going around, but until, and many other companies pulled out because of events, right? And so I figured, well, let's not let the system go to waste. And so Ryan did a video of this, with, I think, single drive performance he put on Twitter.
Mm-hmm.
And then I figured, well, what the heck? We live, the guys can't come to CES. I can probably bring the demo to them, to a couple of them. So
cool.
I went down to Wendell yesterday, level 1 techs, and I'm here with you. And I think those are the only two folks that I know of that are within
Kentucky.
Within Kentucky/Cincinnati driving distance, yeah.
All right, we're going to fire this thing up and show the performance of these two drives and see what this thing can do. We're just take a uncharacteristic break in the pod, move some stuff around, and then come right back. All right, so welcome back. What we've done is run power and HDMI to this system. It's blue, so that must mean it's running. Nice. Your cable management's actually pretty exquisite there for a test system.
I mean, it kind of just slapped it together. And it's actually a little worse for the wear now that I keep throwing it in the back of my car and dragging it around.
It's because you're a terrible driver.
Well, what? I wasn't supposed to autocross all the way here?
Well, I don't care how you get here. I'm just glad you're here. Okay. All right, so we've got both of the 1743s.
Yes.
1743s in the system. They're in the Serial Tech cards. They're in the two designated PCIe Gen 5 lane areas. And what, did you get an email?
No, I'm checking to make sure it's 1743.
Oh, it's good fact check in the middle of the
yes.
thing. And so we've got them set up. You're running some iometer. Let's go take a look at that. Talk to us about what we've got, and understand that this is a pre-production, not even alpha drive. What do we call this thing?
Yeah, this is very early firmware for these Samsung drives. But despite that, they are able to pretty much saturate Gen 5 by 4.
And so this is two, each one doing about 14,000 apiece, right?
Yeah, it's 14 gigabytes a second from each one. It's a little over 14. We have that sitting down there on Task Manager. I have looking at just one of the drives so you can see the number there. But the iometer is showing the total with its little speedometer thing there. And that's running around 28 gig per second. Neatly double. This interesting thing about this config is that Ryan did the demo initially. He posted a video and he only had one drive in. And it actually did only like 13.7, 13.8.
So not quite 14.
Not quite 14 from just one drive.
Right.
And the reason we're actually getting, for most of the time, over 14 from each drive with two of them actually comes down to that this is a complete default config. Like we did zero performance tuning. This is slapped the system together, didn't even take it out of balanced mode. It's still as default as you could possibly get. So in that case, if you're only doing one sequential transfer with one drive, even though you have one core that's loaded pretty high, you still do have, most of the time the system is waiting for the interrupt from the SSD, and like there's a lot of that sort of idle state going on, right? And if you load it down even further by doing that, max transfer rate to both drives, it actually wakes the system up even a little bit further in its default state. So we get even better throughput. We might be able to get even a little higher than that number if we went through and did some server style tuning and disable CMP states.
Oh, sure. Yeah.
You might squeeze a little more out, but we're pretty close to the bleeding edge there as far as that. There's probably not much idle time going on those PCI buses.
Well, you're doing nothing else in the system. You're just running these nice large block sequential read and letting the drives this is their happiest place.
It is, especially for this particular firmware. This is the sweet spot. When drives are more optimized, then you'll be able to throw whatever workload you want at them, and they would do fine, and usually be within their spec and whatnot. But yeah, we're super early on this, so this is really the only thing that will properly show off, the capabilities of Gen 5 and the fact that this platform can do that much throughput.
Well, credit Samsung though too for being willing to let you come out and show this
yeah.
capability.
Yeah, they were super helpful. We came to them and just said, hey, we'd like to show Gen 5 SSDs. It's for CES content. Do you guys have anything? And,
Absent CES,
well,
here we are.
Yeah. I mean, well, CES kind of got aborted a little bit there, but we reached out to them again and said, hey, I'd like to bring this around to some folks and show, and they were happy to do that too. So,
cool.
Yeah.
Well, thanks for doing that and bringing that system over and hanging out a little bit. So as we wrap up the conversation on Gen 5, what are your 2 or 3 takeaways for high-end performance users who think they can benefit from a Gen 5 SSD when they hit the market for client in the next, somewhere 4, 5, 6 months, somewhere in there? What's the takeaway?
Well, it's going to be a niche sort of really high-end power user thing in the first place, right? So get that out of the way right away, because there's plenty of really solid Gen 4 drives out there. There's not this urgent need where everybody is just starved for bandwidth, and they're just most people that have a Gen 4 SSD are probably not even using that to the full capabilities of that
absolutely.
throughput either, right? However, if you have some folks that are doing more, content creation sort of thing, where they're actually getting a lot of throughput to the device and where they might actually notice a difference or some benefit, probably the folks that right now are running some form of a RAID of maybe 2 Gen 4 drives, right? If that kind of person wants to do a build where they don't want to have to worry about the RAID, that would be the person that would probably pick up a single Gen 5 drive when those are available, right? You're going to get most of the same sort of benefits, but just added simplicity, because you just stick one drive in and it just does the thing.
It's not your job, but do you have any sense of price impact of Gen 5 specifically on these?
I would guess that it would be similar to, from Gen 3 to Gen 4. Like at that time when that happened, and you saw the Gen 4 drive start coming, and there was some
little
sort of
premium,
markup.
but not double.
I don't think it would be double,
because the media cost isn't going to change.
Right. I think it might be a little bit more disproportionate in like the more expensive direction for Gen 5 over Gen 4, just because it's going to be that much more niche.
Fewer models produced,
fewer volume, like that sort of thing, at least initially. And I just think the ramp up, because there was such a quick cadence from 4 to 5, that there's plenty of folks that have just now upgraded to a 4, like a 4.0 drive, right? So they're not going to immediately scramble and go and run out. And so there's, the adoption's probably going to be slower. There's just a lot of things sort of working against it, just because it's so fast, so quickly, for single device.
Until PlayStation 6 comes out or whatever that.
Well, so even thinking about that, like there was that amazing presentation that those PlayStation folks did, where they were talking about, not here's this device that can go this fast, but most of their presentation was explaining how they're able to even fully utilize that speed, right? So they had to do a lot of purpose-built or purpose design, software and hardware and firmware, all those things had to line up perfectly just to be able to do what's actually not full bandwidth even for Gen 4. It's actually like a gig or 2 per second shy. It doesn't go 7. I think it goes like 5 or 5.5 or something, right? Gig per second.
Still tremendous.
Still amazing, right? And some of that stuff is also coming down the pike on the PC side with respect to direct storage, and like Microsoft's trying to do that. Yes, it's a little bit of catch up from the PlayStation example, but clearly they showed, hey, this is beneficial to the person if you actually go through the legwork of making all these things, the whole pipeline that optimized, right?
Yeah.
So good on Microsoft for picking up the cue there, and now they're working on it. But even so, like again, going back to the PlayStation's example, are they really going to redesign? They would need more than double the capability of all the texture decompression, all the other things in their whole pipeline to take advantage of a Gen 5 SSD properly. It's probably good enough for them, even for them with Gen 4 speeds right now.
Can you imagine how good Flappy Bird would be on PS6 with all that bandwidth?
The textures
available?
would all just be like real,
real
life.
That'd be sick.
But yeah, I mean, think about that. Gen 4 drives were out for a fair decent amount of time, and just console gaming in general has been around for a pretty long time, number of years, where even if it was SSD equipped, it was nowhere near taking advantage of that full bandwidth. And just now, or well, past months or up to a year, but just in recent time, we get a console that can do the full bandwidth or almost the full bandwidth, right? So think of how long it took to get to that state.
Yeah.
and now you've just doubled, like you just moved the goalpost, double, another football field away, right? So I don't, we need some time for all the other stuff to catch up again before you start seeing everything just start wanting to use a Gen 5 SSD, right?
And just keep in mind the Gen 6 is around the corner, so everything we just said will be irrelevant in probably 12 months. So
maybe, yeah.
That's the fun part. I mean, this cycle right now, innovation cycle, is super quick.
Yeah. Just the thought of potentially getting down to an SSD that'll still do like 6 or 7 gig per second, but be one lane.
And be mainstream value in its positioning.
Yeah.
Yeah.
Yeah. Could potentially be just like a value, like not even a full length M.2, like
BGA.
or a BGA or something
like that.
Yeah. Yeah, could be. Like things will eventually get there anyway. We know it. Like it'd be silly to say it wouldn't get there,
right?
Based on history, right?
Right. Yeah.
So yeah, there's going to be like some budget, $100 Walmart special laptop or something, and it'll have one lane of Gen 6 at some point, right? It might be 8 years from now, but
that's clearly the direction.
Yeah, because why would you?
And at that point, your display will be back to the most expensive component on those value builds, probably.
Could be, but then there'll be quantum dots and OLEDs and all the other things will be thrown in.
I'm not talking to you anymore because we'll keep going for too long.
I could rabbit hole all day.
For everyone else, thank Allyn or not for coming by. If more than 16 of you watch or listen to this, then maybe we'll have him back and talk more about quantum dots and into phase 2. Until then, thanks for tuning in. Bye-bye.